Hello dear students, here Professor Ashfaq Patan, Department of Mathematics, Angry Institute of Technology and Management. So before we've discussed the shifting property of Laplace transform. Now let us discuss the second property of Laplace transform, that is if L of f of t is equal to f of s, that is the Laplace transform of a given function f of t is equal to f of s, then Laplace transform of t raised to n into f of t is given as, that is minus 1 raised to n d raised to n divided by ds raised to n f of s. So therefore it is a product of property, that is a differential property we usually call it as, because we are going to do here the differentiation. Okay, so let us move some examples of Laplace transform. So find the Laplace transform of t into cos 80. So here it is having a product of t into cos 80, where t is having a power 1 here. So therefore, so how to start this example is, let us start like this. So the second function, you have to treat this one as the given function f of t. So Laplace transform of f of t, that is let f of t is equal to cos 80. So you have to find first Laplace transform of this function. So therefore Laplace transform of f of t is equal to s divided by s square plus a square, as you know that is from the formula. Okay, so after this, so you have to do the product of these two Laplace. Okay, so how to find this? The Laplace of product of these two function is given as the formula minus 1 raised to n d raised to n d divided by ds raised to n into f of s, where here n is equal to what? Having a power 1. So therefore I have written here n is equal to 1. So apply n is equal to 1 here. So d raised to 1 divided by ds raised to n bracket f of s is nothing but, this is nothing but f of s. Okay, so f of s, use this f of s here. So therefore now what you have done, minus 1 raised to 1 is nothing but minus sign. So d by ds is nothing but differentiate this whole function with respect to s. S is a function here, so you have to differentiate with respect to yes. So it is u by v rule, apply u by v rule, denominator square, so denominator as it is, then differentiation of s is 1 minus s as it is, then differentiation of denominator s square plus a square is 0, s square is 2s. Now simplify this one, s square plus a square into 1 are s square plus a square minus 2s into s is minus 2s square divided by this term. Now you can multiply this minus sign inside here. If you multiply minus sign inside, it becomes, I can write here minus s square, so minus is okay, so then divided by a square plus a square the whole square, s square plus a square as it is, this one 2s as it is, then a square as it is, then minus 2s square plus s square is minus s square divided by s square plus a square. This is the first example. Now this is the first example I have taken a simple example. Let us move for the little bit difficult example, that is find the Laplace transform of t square sin 80, where t to the power having n here 2. So you have, if it is having more power, so you have to differentiate number of times there. If it is having 2 times, you have to go for 2 times differentiation. If it is having more than 2, that is 3, so you have to go for 3 times. Now let us go for this example, sin t square sin 80. You have to find the Laplace of this one. So first you take the second function as f of t. So f of t is equal to sin 80. So Laplace of f of t is equal to this Laplace transform is a divided by s square plus a square. Then Laplace of this whole term is denoted by Laplace of t square into f of t, that is minus 1 raised to n d square, because n here, n is equal to what here? Having 2. So minus 1 square d square divided by ds square bracket this Laplace transform of sin 80 you have to keep here. Okay, so minus 1 square it become a plus d square upon ds square, that can be splitted as d by ds into d by ds of this terms. So that means you have to differentiate this term with 2 times. So first time you have to go differentiate like this, d by ds as it is, differentiate this one. Okay, how to differentiate? Denominator having a function, numerator having a constant. So therefore you treat this one as 1 by x. Differentiation of 1 by x is minus 1 by square. So therefore differentiation of 1 by s is minus 1 divided by s square. Okay, this a as it is. Then again the composite function is a differentiation of s square plus a square is 2s, a square is 0. So therefore I have written 2s. So one time it is differentiated. Now you call this one as a numerator part, you call it as denominator part, u by v again rule. So again you have to differentiate because you have to go for 2 times differentiation here. So therefore denominator square it becomes 4. So denominator as it is, differentiation of numerator 2a minus as it is, minus 2s as it is, differentiation of s is 1 here, minus rule says numerator as it is, then differentiation of denominator 2s square plus a square, 2s square plus a square, again differentiation of this one is with respect to s is 2s. Okay, then simplify this one. Now see here, minus 2a a square plus a square whole square, minus into minus plus. So 2 2s are 4, 4 2s are 8, 8 a s into s square, this term as it is. Now take common, 2a square plus a square common, 2a square plus a square common, minus one term remains here and plus 4 times s remains here, s square remains here, this is got common. So therefore cancel one term here, it becomes 3 terms here. So 2a as it is, 2a as it is, then simplify this one, minus multiply inside, if you multiply minus a square, this plus 4a square, plus 4a square minus a square is 3a square minus a square divided by this denominator. This is an second example. Okay, so let us go for another one example which is having a power t to the power 3. Now let us go for another one example, the last example here. So find the Laplace transform of t cube sine t, where t is having here, t to the power having n is here 3. Okay, then Laplace transform of this term can be started like this. Let us take the second function as f of t. So f of t is equal to sine t. Okay, then you have to find the Laplace for this one. Later on you have to find the Laplace of this whole term. Okay, then Laplace transform of f of t is sine t is a divided by s square plus a square, that is 1 divided by s square plus a square, where a is 1 here. Okay, then you have to find the Laplace of this whole term, that can be written as Laplace of t cube sine t is equal to the formula minus 1 raised to n. N is here 3. D cube divided by ds cube bracket f of s. F of s is, this is nothing but f of s 1 divided by s square plus a square is equal to minus sign as it is cube, because minus 1 to the power cube is minus. Then you have to differentiate this whole term with respect to s 3 times. Okay, so d by ds and d by ds. Okay, that can be written like this, product of these 3 into the f of s, that is 1 divided by s square plus a square. Then you keeping these two terms as it is, then differentiate with respect to s. So differentiation of this term with respect to x is, that is u by v rule, that is you can take 1 by x also. 1 by x differentiation is minus 1 by x square. Then differentiation of s square is 2s. Okay, so this is a differentiation. Then minus sign as it is, again you have to differentiate u by v rule, denominator square means already it is having a square, it becomes again square, it becomes raised to 4. So denominator as it is, differentiation of numerator with respect to s minus 2 minus as per the rule. Okay, then numerator as it is, then differentiation of denominator, s square plus 1 whole square can be written as 2 into bracket s square plus 1 into differentiation of s square is 2s, bracket complete. So then again keeping this multiplying minus sign inside, so d by ds as it is, multiplying minus inside becomes plus, and this minus into minus plus, again if you multiply this again it become minus. So 2 times s square plus 1 whole square and minus 2 into 2 4 4 2s are 8 8 s into s square plus 1 as it is, and you can take a common here, 2 times s square plus 1 1 you can take a common, so I have taken a common here, 1 terms remains here, s square plus 1 minus 4 times, already you have taken 2 here, you have it becomes 4 into s square remains. Okay, divided by s square plus 1 raised to 4 as it is, one term get cancelled here one term get cancelled, so d by ds as it is, taking 2 outside, this term get cancelled, this term s square plus 1 minus 4s square can be written as 1 minus 4s square minus 4s square plus s square is minus 3s square divided by s square plus 1 raised to 3. Again you have to differentiate third time, so 2 times as it is into bracket differentiate this term with respect to again denominator square, it becomes 6. Denominator as it is. Differentiation of numerator, 1 is 0, minus sign as it is. Differentiation of s square is 2s, that becomes 6x, minus numerator as it is. Then differentiation of denominator differentiation is 3 times s square plus 1 square. Okay, then again the composite derivation is differentiation is s square plus 1 is 2s. Okay, where 1 is 0. Then multiplying this 2 inside, if you multiply 2 inside, it become minus 6 2s are 12, yes, s square plus 1 whole cube. Then again here minus 2 4 3s are 12, 12s, yes, this term remains and this term remains as it is, divided by denominator as it is. Now let us move for further next step, that is minus 12s into bracket. I have taken a common here, see here, I have taken a common, that is s square plus 1 whole square is common and 12s is common, 12s is common, with minus sign I can take a common. So therefore common is minus 12s s square plus 1 whole square bracket, remaining parts are s square plus 1 minus 3 s square divided by s square plus 1 raised to 6. These two terms get cancelled, these two terms get cancelled, so remaining terms are minus 12s as it is. Then remaining term this one and this one as it is, divided by this raised to 4 times. Then minus 12s as it is bracket. So see here s square minus 3s square is minus 2s square, 1 plus 1 2 divided by s square plus 1 bracket raised to 4. Then I have taken a common here 2 with minus sign. 2 common, if you take 2 common, 12 2s are 24, yes as it is. If I take minus, it becomes plus and it becomes interchange here because I have taken a minus sign here. So this s square comes first, then this one comes later, okay, divided by denominator as it is. So this is the second property of Laplace transform, that is called as differential property. So if you get an examples of e raised to at into some f of t, this is exponential, so it comes under first shifting property, where you have to find the Laplace of this one, then later on shift the property, that is s is replaced by s minus a. When second shifting property is given as t raised to n, then f of t, if it is having t raised to any terms, then it is called as differential property. In differential property, first you have to find the Laplace transform of the function f of t, then you have to apply the formula. The formula is minus 1 raised to n d raised to n divided by ds raised to n bracket into f of s. So therefore first you find Laplace transform of f of t, you will get f of s, then you have to differentiate up to n, where having t to the power n, how many times is that, you have to differentiate up to that, then finally you will get the Laplace transform of that given function. Okay, then the next property is having, that is f of t divided by t, that is known as integral property. We'll discuss in next video lecture. Okay, I hope you understand this one. Thank you.